This is lesson 2.4. We did this in class, so I'll just briefly go through some of the things we talked about. Postulate, theorem, and proof. Postulates and theorems are just statements or conjectures. They're logic either proved, postulates are just accepted as logic, theorems are just a conjecture proved by a postulate or another theorem. Once they're proven, we can use them to solve other things. Proof is just a logical argument, that's all it is. I introduced you to these points, lines, and planes. They're on that packet that I gave you. These are all postulates that have to do with points, lines, and planes. Then we talked about how to look at a statement and decide if it's true or false, and to refer to the postulates. So using that to develop our logic. So we did that with these examples as well. Then we talked about always, sometimes, and never. If you were in the first class, I should have said sometimes on A, because it doesn't really state how the lines intersect. So this would be a sometimes. We talked about in the other class how if you have three lines that intersect this, or three planes that intersect that way, then sure, the intersection is one line, but they didn't really tell you which type of intersection it was, so it could be something like this. And if that's the case, and these are the ends of those three planes, you're going to have three lines that also could be the intersection of those planes. Okay, so we talked about always, sometimes, and never. The proof process is just figuring out what's given, using logic, theorems, postulates, definitions as your reasons to come up with a conclusion. So prove that M is the midpoint of AB, then AM is, line segment AM is congruent to line segment BM. That would be theorem 2.1 is what we can use to do that, and that's in your packet as well on the second page. Then we got to the properties. Now if you were in the first two classes, when we got to the examples, I have a correction to make, but this reflexive, symmetric, and transitive properties of equality, those we don't use very often. Transitive is like the syllogism that we've been talking about. Symmetric is you just flip over an equation. That's what allows us to say x equals 4 or 4 equals x. Okay, so then we got to this one. This is where in A, if you were in the first two classes, I was trying to hurry and didn't pay attention to what was going on here. So here's the thing. If 3 times the sum of 4 plus 5 is here, this 3's gone away. And how did it go away? Well, we divided by 3 on both sides. So this would be division, not distributive property. Okay, and then on B, if 4x plus 3 equals y, then y equals 4x plus 3. This would be the A part of the equation and the B part of the equation. And then we went to B equals A. So this is symmetric. The next one, if you look, there's a 25 on this side, and now the 25's gone. So that one, to make that go away, we had to take away 25 from both sides. What permits us to do that is the subtraction property of equality. This next one is a little bit tricky, but look at here. Here's 3x plus 4 and 3x plus 4. Here's the 2, here's the 2, but instead of this y on here, there's 2x minus 1. Here's that 2x minus 1. So what they've done is they've taken this 2x minus 1, substituted it in for the y. So it looks like this. So this would be substitution. And then the last one, this one is transitive. Because if we stack it up vertically, this looks like the line 1, line 2, line 3 of our syllogism. So transitive and syllogisms are similar. You already know how to prove because you've been solving equations. You just haven't written out the steps and the logic why. So we're going to use things that you already know, like solving this equation, to help us develop an algebraic proof for this. Number 13 and number 30 in your homework are the ones that do the algebraic proof. Please set it up like this. So the first thing you do is you write your given statement. And you write given right here. You have to write given right there because it'll set you up for doing the other reasons in the right position. Okay, to go from here to this next step, what did we do? This is where we distribute. So I took the 2 and distributed it. The reason why is because I am able to with distributive property. Allows us to do that. Okay, so then from here I'm going to take away 14. But we usually don't show that on the steps. If you want to put it in between the lines, you can. But the next step of this solving would be 2x equals -8. How we did that is we did it by subtraction. So this is a subtraction property. And then to get to the answer, one more step left, what do? We divided by 2. So this is the division property. So the first thing was given. Then we went to the next line. The reason for that is the distributive property. Then we go to the next line. The reason for that is substitution. The thing that gets us to this last step is division. To solve something like this, you're going to do the same thing. We're going to take away 5 from both sides. Then we're going to divide by 20. And then we're going to use one of the properties to do this, because there has to be a reason why you do every step. So there has to be a reason why you switch the sides and make it symmetric. The first step, the reason was given. To go from step 1 to step 2, what we did is we subtracted 5 from both sides. The next one we did division property. And then the last thing we did is we flipped the sides, so this is symmetric. Okay, so you're just writing the steps. Given is always the first one. This one is pulling in a little bit of our geometry. So with the geometry on this, most of you know the steps that we do for this is that we put 4x minus 6 equal to 22, and then you solve it. But we're going to start with one step at a time with reasons for why we do everything. So FG is congruent to HK. The reason why is because that's given. The next step on this is going to be to change the congruent symbol to an equal symbol. So FG equals HK. And the thing that allows us to do that is called the definition of congruence. Okay, and then we're going to change the FG to 4x minus 6. Change the HK to 22. The reason why we can do that is substitution. From here, it's just like we were doing before on the others. We're going to add 6 to both sides. So this right here was addition. And then we're going to divide by 4. X equals 7. That would be division. So that's it. There you go.